Assalamualaikum warahmatullahi wabarakatuh. Before we start our meeting, let's pray to Allah. Okay, my students, how are you today? I hope you still healthy and safe in this pandemic. Okay, in this meeting, we are going to study about Faraday's law and Lenz's law. Our learning objectives in this meeting are: students can understand about Faraday's law and Lenz's law. In the last meeting, we have studied about Oersted experiment. In 1820, Hans Christian Oersted do experiment like this. In this experiment, used rheostat, battery, conductor wire, and magnetic compass needle. Initially, when there is no current passes on the conductor wire, the magnetic compass needle shows no deflection. Then there is current passes a conductor wire and magnetic compass needle shows deflection. The magnetic compass needle shows deflection while the current electric passes the conductor wire. It means there is a magnetic around the conductor wire. Then Hans Christian Oersted make conclusion that electric current creates a magnetic field. One question scientists hoped to answer was, if current can create a magnetic field, then can a magnet be used to create a current? To answer a question from the scientists, in 1851, Faraday did experiment. And in this video, in demonstration in this video, is similar to the experiment of Faraday. In the video, consists of magnet, a coil, a lamp, and a voltage. Pay attention to the galvanometer needle when a magnet moved toward to the coil and when magnet moves away from the coil. Magnet moves slower, and pay attention to the deflection of galvanometer needle. Then discuss with your team about the question below. There is 4 questions. Where the direction of the galvanometer when the magnet moves close to the coil? And there is counterclockwise or clockwise. And where the direction of the galvanometer when the magnet moved away to the coil? And why it's happened? Then how the deflection of the galvanometer when moves slower? And then where the deflection of the galvanometer when magnet raised on the coil? Based on the results of your discussion, we know that a magnet can create electric current. Now we prove that use the virtual laboratory. In the virtual laboratory, there is magnet, the coil, a lamp, and a voltage. There is no current passed on the circuit. Now we move the magnet toward and forward from the coil. Pay attention to the lamp and to the galvanometer needle. When we moving a magnet closed and away from the coil, the lamp is on. But when the magnet in race in coil, the lamp is off. How about we move the magnet with different velocity? Pay attention to the lamp and to the galvanometer needle. And the second, more slower than before. Is that different from? Is that different like from the lamp? When we moved magnet faster, the lamp is lighter than when we moved slower. Magnet can produce electric current if there is magnetic flux change. When we moved the magnet on the coil, so the lamp is on. But when magnet at rest, the lamp is off. So there is magnetic flux change on this case. So what is the magnetic flux? Magnetic flux depends on magnetic field, the area of the surface, and the angle between magnetic field and normal force of the surface. And process produce electric current with this way. It's called electromagnetic force. And electromagnetic force depends on magnetic flux change every time. Change in the field flux magnetic every time caused the change of the voltage. The voltage in this case called electromotive force induction. And the magnetic field flux depend on magnetic field. A is surface of the area and cos theta, where theta is the angle between magnetic field and the normal force of the surface. And this formula called Faraday's law. What if we use a coil with a little twist? We use this one and compare the light produced by the coil, this one and this one. Pay attention to the light of the lamp. Then we try with coil. The light produced when we use its coil is lighter than the coil with more twist. So the number of the turn also influence induced electromotive force. Note that if we hold the magnet from the right to the left, approaching the coil, the voltmeter hand is counterclockwise. Based on the Lenz's law that the induced magnetic flux is resisting change, when the magnet is moved closer to the coil receives a lot of magnetic flux. So the induced magnetic flux is resisting by reducing the magnetic field, so that the direction of the induced magnetic field goes to the right. By the rules of the right hand, the direction of if the magnetic field to the right, so the current is down. How if we moved the magnet from the coil toward the right? Then the magnetic field received by the coil decreases, so that based on Lenz's law, the induced magnetic field opposes the flux change. The induced magnetic field must increase so that the direction of the induced magnetic field to the left. So based on right hand rules, the current is upward. Okay, after we have learned about Faraday's law and Lenz's law, let's do the working example. A 200 coil square shape with a side length of 18 cm, the magnetic field perpendicular to the coil. If the magnetic field change from 0 to 0.5 Tesla within 0.8 seconds, the induced electromotive induction during this time interval is answer. Okay, we know that the surface area is 0.18 square, then 0.0324, and the magnetic change 0.5, the time change 0.8, and because the magnetic field perpendicular to the coil, so the theta is 0. Then we use the formula Faraday. In this case, only magnetic field change and time, so the formula we use dB divided dt, and we get the value of the electromotive force induction is 4.1 volt, and we don't have direction because there is no direction known from the equation. Okay, there is the conclusion of this meeting. The first Faraday's law. Electromotive force induction depends on the speed of motion of the magnet or coil, the number of turns on the coil, and the strength of the magnet. And the Lenz's law, the direction of the induced current is such that the induced magnetic field opposes the change in the flux. And the application of the Lenz's law and Faraday's law in daily life is in generator, bicycle, car, power plants, and the other. So next meeting we study about generator AC and generator DC, and let's pray to Allah. I hope this material can give us so many hikmah in our life.